So this problem has an inverse trig function, and if I think about the I inverse trig function, there it is. This is going to be u, and then everything else, dx, will be dv. So I'm going to say u equals inverse cosine of x. What is the derivative of inverse cosine of x? Well, I'll tell it to you. Negative 1 over the square root of 1 minus x squared. So that's something from last semester. And so du is negative 1 over the square root of 1 minus x squared dx. dv will be dx. V is the integral of dx, so v will be x. So for this problem, I'm going to get u times v. Again, I'm going to write it as v times u, x times inverse cosine of x, minus the integral of v du, negative 1 over the square root of 1 minus x squared dx. Let me separate that out here. And I got to remember, this is a definite integral, 0 to 1/2. And although this is also 0 to 1/2, sometimes for this, sometimes I just wait and plug the numbers in after I'm done with all the integration. And if you like, you could plug this in right here, kind of your choice there. I'm going to tackle this part. I got minus a negative, so that would be a plus in front of the integral. So I'm going to hold off on that x inverse cosine of x. This is now plus the integral of 1 over the square root of 1 minus x squared x dx. And I got to remember my 0 to 1/2. Who knows what to do here? I'll say u substitution, but we've already used a u in this problem, so I'll call it w substitution, but it is substitution. So for this part, I'm going to say w is 1 minus x squared, then dw, derivative of w is negative 2x dx. So if I solve this for x dx, dw over negative 2 is x dx. So this part of the problem, now also, well, let me write this. 1 over the square root of w, dw over negative 2. Now what I've written is not quite correct in the sense of 0 and 1/2. Those are numbers for x. So I like to leave them as x and then resubstitute the x back in instead of worrying about changing the 0 to 1/2 to match w. Your choice, but that's my choice right now. So I'm going to leave it. I wrote equals x to remind me those are not values for w. Let's see. I'm going to have x times inverse cosine of x from 0 to 1/2 plus, I told you I write a lot of steps. Let me pull out that negative 1/2. And this is going to be the integral of w to the negative 1/2 dw. Again, those are values for x. What's the antiderivative of w to the negative 1/2 dw? going to be, let me write all this and then I can think about it. So this is minus the 1/2 I took out. Now this will be W to the positive 1/2, add 1 to negative 1/2, and then if I have fractions, I usually skip a little space because then I can say times the reciprocal 2/1. There it is, 0 to 1/2. Those are values for x. So 1/2 times 2, those cancel. And let me go ahead and put my x back in there. W is 1 minus x squared. So x times inverse cosine of x from 0 to 1/2 minus, I'll use parentheses, 1 minus x squared to the 1/2, and that's going from 0 to 1/2. Let's plug in the 1/2. 1/2 times inverse cosine of 1/2 minus 0 times inverse cosine of 0 minus, here's the second part, 1 minus 1/2, that is squared. That whole thing is to the 1/2 minus, open parentheses again, 1 minus 0 squared, and that whole thing is to the 1/2. Oh my gosh, this does not, this almost looks like a little exponent after I have all those 1/2s, but it's not. Those are the numbers I'm plugging in, right? All right, so let's see. 1/2. What's the inverse cosine of 1/2? Remember the unit circle? It is pi over 3. Yes, indeed. Unit circle, cosine is 1/2 at pi over 3. Now here, the inverse cosine of 0 is 1, but what's 0 times 1? 0 minus 0. I always slow down when I have a lot of negatives I'm distributing and stuff like that. See, I might not need the minus. Still using my bracket. 1 minus 1/4, and that's to the 1/2. 1 minus 1/4 to the 1/2 minus 1 to the 1/2. 1 minus 1/4, that is 3/4. So here, let's see, let's back up to here. Pi over 6 minus 3/4 to the 1/2. And then what about this guy? Plus or minus? Plus 1. There's the answer. You could write it as pi over 6 minus the square root of 3/4 plus 1.